the properties of logarithms are kind of like the properties of exponents. For example, we know the product of powers property of exponents, where if we have 3 squared times 3 cubed, that's equal to 3 squared plus 3. So 3 to the 5th, where you add the exponents. More generally, if you have like a base and an exponent times another exponent with the same base and a different exponent, you've got b to the x plus y. And that is the product property of exponents. So we can do the same thing with the properties of logarithms. So we have 3 properties of logarithms that I believe we really care about right now, which is the product property, the quotient property, and the power property. I'm going to show you where the product property comes from. I'm just going to say, believe me on the others unless you want to derive them yourselves, and then we'll start going over some examples. So the product property says that if you have the log base b of a product of 2 numbers, that's actually equal to log base b of the first number plus log base b of the second number. The quotient property, it's a little bit similar, and then it says if you have log base b of a number divided by another number, that's log base b of the numerator minus log base b of the denominator. And the power property says if you have log base b of some number to a power of n, that you can just kind of like factor out almost the exponent and rewrite that as n times log base b of m. These are the properties of the logarithms that allow you to manipulate logarithmic expressions. I'm going to write that down. I'm going to do a proof of the product property. It's actually dependent upon the property of exponents. I'm going to define some exponents here. I'm going to define just a general base b to x as m, and b to the y as n. Keeping in mind that if I were to rewrite this as a logarithm, that would just be log base b of m as x and log base b of n as y. Notice I'm using a base of b, I'm using m, and I'm using n. And so what I'm going to do is I'm going to actually take a product of m and n. I'm just going to say I'm going to multiply m by n, but I know that m is equal to b to the x power, and I know that n is equal to b to the y power. So if I define b to the x as m and b to the y as n, then the product of m and n is just b to the x times b to the y. There's not much we can do here, except we see that b to the x times b to the y is the same as b to the x plus y because of the product property of exponents. Well, if you recall, if we have a base and we have an exponent and we have a result, we can simply write that as a logarithm, where I have a log with a base of b of the result, which here is m times n, is equal to the exponent, and the exponent here is x plus y, where x, written as a logarithm, is just log base b of m. So my x value here is log base b of m, and my y value is log base b of n. That's one way that we can prove the product property of a logarithm.